All right, so in exponential growth, we have that basic formula there. If there is no a value out front, the a value is 1. To graph these without a table, okay, your first point is always going to be 0a. Your second point is going to be 1a times b. And then if there are any transformations to be done, left, right, up, down, reflections, then we will deal with those like we did in those tables with transformations. So if I was to do those basic points for this very, very basic exponential growth graph, what would my first point be? 0, 1, because that a value out front would be 1. My second point would be 1, what? 2. Okay, if there is no a value, that means that your base will be the second point, and that will just give you enough to graph that, knowing that your asymptote always starts at 0. Okay, y equals 0. Okay, and we talked about your range is 0 to infinity. Your domain is always going to be negative infinity to infinity. Okay. Decay functions work the exact same way. Just to figure out if it's a decay function, if you flip to the next page, if it's a decay function, notice that your base is between 0 and 1. So again, we're not worried about that a value at all. That a value out front can be negative, it can be positive, it can be whole numbers, fractions, it doesn't matter. We're only worried about the b value when you tell me exponential growth or decay. So that's 1/2, 3/4 fractions that are between 0 and 1. Okay? We've already graphed that function, so I'm going to go ahead and talk about 3 and 4 down here to talk about how we can use transformations to do any of this graphing. So remember, for all of these, we have your basic function y equals a times b to the x power. Your first point is 0a. Your second point is 1a times b. So that's how we're always going to start. So in a question like number 3, first let's just identify what's a and what's b. It's easiest to first identify your base because that is directly below the exponent, and then go to find your a value. Keep in mind for this, your base can never be negative. But also in 3, why do I know my base is not negative 5? What would it have to have? Parentheses. If my full base was negative 5 there, it would have to show it in parentheses. So in this question, my base is 5. What's going to be my a value then? Negative 1. So to start off with, what are my 2 basic points that I start with before I do transformations? 0, negative 1, and 1, what? So 1, negative 5 is my second point. Then I worry about the transformations. If there are transformations, I'm going to add to this basic equation we've done up here. We're going to say plus or minus h in the exponent and plus or minus k at the end. If you had to guess something in the exponent, does that affect the x's or the y's? Based off of what we know of your transformations. All right, so that's going to be your left or right shift. But it works the same way transformations did before. It's the opposite of what you want to think. So if it goes left, what's it going to show? Positive. And if it goes right, it's going to be negative. The plus or minus k here, this is going to be your up or down. And that will be just like normal. Which of those two are going to affect the asymptote? The up and down, because it's a horizontal line, it's only going to move up and down. You can move horizontal lines left and right, and it doesn't change them at all. All right, so using that, in 3, if I have a minus 2, what does that do to my 2 points? It moves them left or right? It moves them right, because if it's the left and right, it does the opposite. So I go ahead and just do that on my points before I graph. If I move them right 2, it's going to change this one to 2. And this one to 3. If it just moves right, does that move the asymptote at all? No. So I have the point 2, negative 1. And I have the point 3, negative 5. And I have an asymptote at 0. So when I connect my dots here, that's always the key, knowing how to connect your dots. Go left to right. So if I'm going left to right, this left side is the side that is closer to the asymptote, and the right side is the one getting further away. Not based off of the graph, would you call this exponential growth or decay? This is a growth function. Why? B is 5. So this is a perfect example of why I tell you for exponential growth and decay, do not look at the graph. This function is continuously decreasing, right? It's always going down left to right. Doesn't matter. It's still an exponential growth function. What changed the look of the graph? The negative out front just flipped it down. So you always need to look at your base. Yes, ma'am?
So is the asymptote always equal to 0?
Asymptote starts equal to 0. It's going to change when we see stuff like this in number 4. That's going to move it based off of the up and down. But it always starts at 0. So if I had to fill out these 3 blanks down here, my asymptote still remained at y equals 0. What's my domain always going to be? Negative infinity to positive infinity, or all real numbers. You could do that as well. This one I have to think about my range, bottom to top. Okay, where's the lowest y value for this? Negative infinity. It comes up and gets real close, but doesn't touch what? 0. So parentheses. Yes, ma'am.
So for it to be a decay, does it technically just have to be a fraction?
For it to be decay, it has to be a fraction that is between 0 and 1. Because I could do like 5/4, but that's still larger than 1.
So it will never be like a -5 or anything like that?
The base will never be
It's always
negative.
like a fraction like this.
Yep.
Okay.
Yep. All right, so for something like 4 then, we're going to start off identifying our A and our B. We'll graph a couple more of these. This is really the only concept we're learning today, how to graph these. So this isn't like a whole lot of stuff. We'll repeat it a couple times, and we'll be done. If I'm to start off with in number 4, what would be my A, what would be my B? A is 1, B is 2. So what are my original 2 points to start off with? 0, 1, and 1, 2. If there is a negative in the exponent with the x, what is that going to affect? The x or the y? The x. It's going to make all of your x's what? Negative. That doesn't change your 0. It just is going to change your 1. Then what's the -3 going to change? The up, down. So it's going to move each of my y values down 3. It's also going to move what? The asymptote down 3. So that's the first thing that I graph. Because I'll be honest, the biggest thing I see on this when people get it wrong is that they forget to move the asymptote, and then they're like, wait, why is my graph going through my asymptote? Because if you don't move it and it stays at 0, your points are going to go directly through it, and you have no idea how to connect them. So draw your asymptote first. It's going to be at -3. You have a point at 0, -2, and you have a point at -1, -1. So then again, the key is, how do I connect these dots? Well, think about left to right. The left point is higher. So that means on this graph, the left side of my graph is higher, and the right side of my graph is what's closer to the asymptote. So that's what's going to level out at the asymptote down here. Okay? Even though it looks like this, which is what looked like an exponential decay function, what is this one? This is still growth. Okay? The 2 tells me that it's growth. The negative in the exponent is what flipped it backwards and made it look like a decay function, but it doesn't matter. It's still growth. Okay? Does that change my domain? Nope. Range on this one, what's the lowest value it gets close to? -3 out to infinity. Good.
So is on the range, is it always the...
All right, so take a minute, try 5 on your own. We're not going to worry about 6 because the exponent's weird with it flipped backwards. And then we'll talk about 7 and 8 together real quick. Yeah, why would we do that? On 7 and 8, if we were trying to be kind to ourselves, we need to move these back to more of a central spot in the graph. Because right now, they're kind of all over the place, right? So, what you need to do is take the lower point on the curve, and you need to move it back to 0, 1. Okay? If I wanted to move it back to 0, 1, why would I want to do that? My first basic points are 0a, 1a times b. If I move it back to 0, 1, what's that automatically making as part of my graph? It's dealing with the transformations, but it's also making my a value what? 1, which makes it a whole lot easier. If you don't make an a value of 1, it gets to the point that it's very difficult to find your base. So to move that point back to 0, 1, which way did I have to move it? I had to move it right 6 and down how many?
2.
Down 2. Now keep in mind you're moving it back, which means that that is the opposite of the transformations, right? So really, when it moved backwards, right 6 and down 2, you have to think the opposite for your transformations, okay? So that means in my exponent, I would instead be showing left 6. How do I show left 6? Plus 6. And instead of down 2, I need to show up 2, which I would show at the end with a plus 2. All I need to know still is my base, right? To find that, we're also going to move that second point back the same amount and see if that will help us. If that second point also moved right 6 and down 2, it lands right where? 1, 5?
Yes.
Okay. If it is 1, 5, and this is an exponential function, 1, and over here is 5, what does that tell me my base has to be?
5.
5.
What? It's
Because you already established that your a value is 1 on purpose, so that helps you much easier find your base of 5. Okay. Let us try that again with the next one. Okay. To start with, we take the lower point on the curve and we move it back to where? 0, 1. So if I'm moving that point back to 0, 1, I have to move it left how many? Left 4 and up 5. But that's really the opposite of your transformations.
Why that point instead of
It's the lower point is always the one that you start with, just because that's this point. Always. The closer to the asymptote one is the 0a, so that's the one that you want to establish as 1. So then if I start with those transformations and going backwards, that means instead of showing left 4, I need to show right 4. How do I show that in my exponent? X minus 4. And how do I show up 5? Plus 5, or opposite, sorry, minus 5, right?
Oh, I thought it was a negative.
It is, but you're moving it up to 1.
Oh.
Okay, so that's going to be minus 5 there, and that leaves all that I have to do is find my base. All right, so that means I need to take that top point and move it backwards. Okay, if that same point moved left 4 and up 5, it lands it right up here. That point is the point -2 up 9. To find your base, you're asking yourself, what number to the -2 power gives me 9? 1/3. Okay? If you don't know that, instead of saying what number to the -2 gives me 9, you can say what number to the +2 gives me 9. You should know that one, right? That's 3. If it's -2, it just makes it into a fraction. So that's 1/3. These are more challenge type problems, but they're worth talking about just because it's good to know how to work backwards. That would be, what? That would be a decay function, yep.
So whenever it's a fraction,
Whenever it's a fraction base between 0 and 1, it is decay. Yep. The only other thing that we do with this is use the exponential function with a base e. It doesn't change how we graph. It just makes it a little bit more messy. There's this whole proof right here of what e is. I'm not going to go through that. What you need to know, because all of this graphing is going to be non-calculator, what you need to know is this. E is a number like pi. We round it to 2.718. Because of this kind of stuff, I will usually give you the little 5-function calculators for the quote non-calculator section on this, because I'm not expecting you to multiply that by hand necessarily. What this does for us, it doesn't change anything. You just have to know what base e is and use that to graph. So on the next page real quick, we're going to go quick through one of these. I don't think you really need me to do more than one because, like I said, we've always done the graphing the same way. Just like before, we're going to graph using 0a, 1a times b. In a question like 2, remember we identify our base b first. What's your base b? E, which is that 2.718. What's your a value in this one? -1. So if I had to start off with my 2 basic points, 0a, 1a times b, I'm going to do that a times b in decimal form because it's easier to graph. So my first point would be what? 0, -1 would be what? 1, -2.718. Then we deal with the transformations. The only transformation we have is up 5. So what's that going to affect? The asymptote first. That's going to move your asymptote up to 5. And it's going to change your x or your y values. It's going to change your y's. It's going to move this one up to 4. And this is why I would give you the 5-function calculators, because I'm not necessarily expecting you to do -2.718 plus 5 on your own. That gives me 2.282-ish. So I have 0, 4.
wait, -2.7 plus 5 is that?
Yep. It is. And 1, 2.282, you just kind of estimate where that is. Which side of this graph is going to be closer to the asymptote then? The left, because the left point is what is closer to your asymptote. The right point is further away. The key with base E is always 2.718. So what does that mean about anything with a base E? Growth or decay? It's always growth. There's no way for base E to be decay. Okay? Domain for every single one of these functions is, okay, are all real numbers. Range on this one, up to 5. Your asymptote is at y equals 5. Domain is always all real numbers for these. Always. Same as -infinity to infinity. All right? Homework for this. If you flip to the following page, exponential functions, we are going to do 1 through 12. 1 through 12 on that one. And then more exponential functions. Let us just do 1 through 4. 1 through 4. However, on number 4, on that one, the exponent's a little bit weird. So follow with me on number 4. First, you have to flip it backwards. And that's going to make it, the exponent on that one, what? -x plus 3. And before you graph that, you also have to factor out a negative. So that's going to look like this. So when you do your transformations to that, first you're going to multiply the x's by -1. Then it's going to move your x's which way?
Right.
Right 3. Okay. All right.